Welcome back. In this tutorial, we're going to discuss how to find the equation of a tangent to a circle. Right, maybe let's discuss what a tangent is. We've dealt with tangent in other topics like in Euclidean geometry. We know what a tangent is. Remember, a tangent is a straight line that will touch a circle at one point. Let's say we have this circle. We can have a tangent like this, which is touching the circle at one point. A tangent is always perpendicular to the radius. A tangent is always perpendicular to the radius. So this will assist us a lot to find the equation of a tangent. Since a tangent is a straight line, we're going to use our general equation, which says y is equal to mx plus c, right? Or you can say f of x is equal to ax plus q. It's just the same thing. Right, how are we going to do that? We can do that by finding the gradient of the radius. Let's say we have this center, which is O, and then let's call this point B. So we can find the gradient of OB, and then after finding the gradient of OB, we can easily find the gradient of the tangent. Remember, the product of the gradients of the lines that are perpendicular to each other is -1. We can say that the gradient of the radius times the gradient of the tangent must give us -1. Or we can say the gradient of the radius and the gradient of the tangent are negative reciprocals of each other. Maybe let me remind you what negative reciprocals are. Let's say we have 2. 2 is just like 2 over 1. So the negative reciprocal, you invert this. Okay, it becomes 1 over 2, and then you put negative like that. Okay, generally we can say a over b, the negative reciprocal is going to be negative b over a. If it is 3 over 4, the negative reciprocal is going to be negative 4 over 3. If it is 10, the negative reciprocal is going to be negative 1 over 10. Or if it is negative 1 over 2, the negative reciprocal is going to be 2 over 1, which is actually 2. But if you want, you can use this general formula. Right, then how are we going to be able to find the equation of the tangent? That's what we want to find. So after finding the gradient of the radius, we can find the gradient of the tangent. Right, so the first step is to find the gradient of the radius. After that, find the gradient of the tangent, and then after that, use this general equation to find the equation of the tangent. You'll be having the gradient and also the coordinates of this point. Maybe let's look at an example. Right, the example says, given the equation of a circle, right, this is the equation of the circle. So this equation shows us that this circle is a center at the origin. Determine the equation of the tangent if the coordinates of the point of contact are at B there, 2 and -2 like this. So what do? We need to find the gradient of OB. So we say the gradient of OB, which is going to be y at B minus y at O over x at B minus x at O. So the gradient of OB is equal to -2 minus 0 over 2 minus 0 like that. And then what do you get? The gradient of OB is equal to -1. Right. And then the gradient of the tangent is going to be the negative reciprocal of -1, which is 1. Or you can say the gradient of tangent times the gradient of the radius, which is OB, is equal to -1. So meaning that the gradient of the tangent times -1 is equal to -1. Then divide by -1 on both sides of the equation. You find that the gradient of the tangent, right, is equal to 1. Now we have the gradient of the tangent. So m is equal to 1. Right, so we're going to use the equation of a straight line because a tangent is a straight line. So y is equal to mx plus c. And then we're going to use this point B. Where there's y, we put -2 is equal to m, the gradient is 1. Then where there's x, we put 2 like this, and then plus c. And then we're going to subtract 2 from both sides of the equation. We get -4 is equal to c. Therefore, the equation of the tangent is y is equal to 1x and then minus 4. That's the equation of the tangent. Right, let's look at another example. Right, it says the equation of a circle is given like this: x squared plus y squared minus 8x plus 6y is equal to 15. Determine the equation of the tangent at point Q. So now, this one we don't have the coordinates of the center. So how are we going to get the coordinates of the center? We have to complete the square so that we can change this equation to this form: x minus a squared plus y minus b squared is equal to r squared. So to do that, we have to complete the square. Right, so what we're going to do, we bring these ones with x closer to each other. So we have x squared minus 8x, and then we have the ones with y, and then plus y squared plus 6y is equal to 15. Now we complete the square. Let's start with this one. So we're going to divide negative 8 by 2, which is negative 4. And then we square that. And then we add it on both sides of the equation. So negative 4 squared. Negative 4 squared. Please take note, write it as negative 4 squared. The half of negative 8 is negative 4. So I'll show you why I'm doing that. So x squared minus 8x, and then plus negative 4 squared. Write it like that. And then we're done with this part, and then is equal to 15, and then we add it again on this side. Okay, and then do the ones with y is going to be plus y squared plus 6y, and then half of positive 6 is what? Is positive 3. So add positive 3 squared. Okay, and then plus positive 3 squared. This makes it easy to factorize this. The first part, just take the x and the negative 4 here and form your bracket. X minus 4, and then becomes our first bracket there. It becomes x minus 4 squared. So that you don't do the long way of finding the trinomial and finding the factors. This is going to be a shorter way of factorizing the first part. Do the same thing with the second part. Is you have your y, and your plus 3. So form your second bracket there, y plus 3 squared, like that. And then is equal to, and then put this in the calculator. This will give you 40. Now we have the coordinates of the center of the circle. You can say the center now is coordinates of what? This is negative 4, it means it's going to be 4, and then negative 3. These are the coordinates of the center. Okay, and then we have point Q. We're given point Q, and then point Q we have 2 and negative 9. So it means we're having what? We're having a circle like this, and then it is a center where the coordinates of the center are what? 4 and then negative 3, like this. And then we have point Q with the coordinates of what? Of 2 and negative 9. If you draw a diagram, it becomes easy for you to understand. And then we have the tangent like this, which is passing through point Q here. Right, so we can start by finding the gradient of OQ. So the gradient of OQ is equal to the change in y over change in x. So it's going to be y at O minus y at Q over x at O minus x at Q. Right, so MOQ is equal to y at O, that is negative 3 minus negative 9, right, over x at O, that is 4, and then minus 2. So which is like the gradient of the radius is equal to, this is like 6 over 2. 6 over 2 is equal to 3. Now this is the gradient of what? Of the radius. And then what will be the gradient of the tangent? The negative reciprocal of 3. Okay, you can do this equation. M of OQ times M of tangent is equal to negative 1. But if you can check, you can see that the negative reciprocal of 3 is actually negative 1 over 3. So you can say the gradient of the tangent is equal to negative 1 over 3, like that. Okay, and then we can use our equation y is equal to mx plus c, and then where there's m we put negative 1 over 3, and then where there's y we put negative 9, and then where there's x we put 2, like that. Okay, and then becomes negative 9 is equal to negative 1 over 3, and then 2 plus c, and then becomes negative 9 plus 1 over 3 times 2 is equal to c. can put this in the calculator. It must give you negative 25 over 3. So C is equal to negative 25 over 3. Right. So the equation of the tangent now becomes y is equal to, our gradient is negative 1 over 3, x, and then minus 25 over 3. That's how we find the equation of the tangent.